Hello, everybody. My name is Steve Taylor, and welcome to Adding Microservice Tracking to Jenkins with Ortelius. So one of the things we do is we love Jenkins. We know that Jenkins can do a lot for us, and we want to see how we can evolve Jenkins to work with hundreds of microservices. We've had a significant increase in microservices. 6 to 8 months ago, it was 30 microservices companies had, and now we're into the hundreds, 200s, and we foresee a lot of people approaching the 1,000 mark here very quickly. So just to give you a little introduction about myself, again, Steve Taylor, cloud native evangelist and passionate about microservices. I am the CTO of DeployHub and the co-founder, the community director for the Artillerius open source project, which is under the CD Foundation. And I'm the creator of OpenMake a build management solution that allows me to have the DevOps experience for over 20 years. If you want to chat, just go ahead and reach out to me on LinkedIn. There's my LinkedIn address. So let's take a look at where we are today. So today we typically have monolithic applications, and those monolithic applications are configured statically during the compile and link process. And this all happens way early in the build process. In the pipeline process. So this is happening at the CI level. So we have the developer checking in the code, and from there it gets compiled and linked. And we create this monolithic application that has everything resolved at that point. Typically, there's a build manager or build meister that is responsible for the scripts that are going to be used to create that monolith application. These are in the form of Maven scripts, Gradle, Ant, make scripts, Meister's build configuration files. Any of that is used to pull together the pieces that we need for creating our monolith application. What ends up happening in that process is we end up interacting with our version control like Git. We pull our code down. We'll interact with artifact repositories. If we're building a Java application, we'll be interacting with like Nexus or Artifactory, some sort of Maven repository to pull and push artifacts to. And what ends up happening in this process is we have our big build that creates our application binary, and we know that it's a specific version. We've pulled together these pieces and of source code and libraries, and we've stuck them all together and packaged them into our basically our application executable, and that's going to get versioned into a repository. From this, we can actually see a bill of material for actually what went into the build at that time, so we can get the dependencies. Also, we can compare what happened from the previous build. We are so close to the Git repo at this point that we can actually see coding changes by comparing commits at that level. So it makes it very easy for us to actually have a version of our application. We can move that version around. It's usually a single file or a couple files. We can see what's in it, and we can see what's changed. Now, when we look at microservices, one of the goals of microservices is that they're built and deployed independently. They're supposed to be loosely coupled, and this means that they can have their own path through the life cycle. A microservice developer will typically be working with some flavor of a container. It may be serverless, like a Lambda function, or it may be a Python Flask that's being put into a Docker container that's going to run in Kubernetes. Now, what ends up happening is when we start thinking about a microservice, these are very small transactional level pieces of code. So the goal behind a microservice is to handle only one specific set of functionality. So if I want to get the user profile, that's the only thing that's going to do. It's not going to deal with login or credit card payments like a monolith does, where monolith has to do everything under the sun. The microservice is going to have one specific function that it's going to do. And because of this, we're going to have lots of them. We're going to have lots of different independent microservices. They may talk to each other, and we may have dependencies between one version of microservice to another. But the whole goal is to make them backward compatible and independently deployable. But as we look at what happens when we go from the dev world to testing, we actually keep on duplicating or redeploying existing images out to these different environments. So if we have 30 microservices that our application is made up of, and we have 4 stages to our pipeline, we could potentially, depending on how we architect things, end up with 120 different microservices that we need to keep track of. We know that there's going to be duplication between all the different stages of the pipeline. We're the same, we don't change every single microservice for every single deployment. So in the microservices realm, we are doing a loosely coupled type of architecture where we actually are actually linking at runtime. In the monolith, we're doing the link and resolving all of our dependencies at build time. Here with microservices, we're actually resolving those that link step at runtime. So this is after the release has been completed. In the monolith, we resolve it before a release is done. So what's this? What happens when we deal with this large number of microservices? We find that we don't have a clear understanding of what clusters have a microservice on it, or which namespaces need to be updated. It's very hard if you have a good number of microservices to figure out who's consuming mine. Like I talked about, we have the possibility of a service-to-service relationship, or a service to the consumer side. We need to know who's using it. So if I need to change it and cause a breaking change, I have to know my blast radius. Who am I going to impact? Or if I have a bug, and I need to let other teams know that there's this bug that we're going to fix, who do I need to update? So it's really important to find out who's consuming my service. Then also, once we roll a service out, how are we going to test it? What is the logical application that we need to test? Are we going to just do a string test on the service itself and say that it's good, or do we want to tie it together with all the other services in like the consuming front end piece and do a full test as part of that process? The one thing that we don't really want to do is wait and deploy, wait for an incident after we deploy. So we want to be proactive and not reactionary as part of that process. In order to get there, we need to reimagine our process. So how do we do that? We can think about our continuous integration process and the build step a little bit differently. We have to think logically. Instead of trying to piece it all together and do a monolithic type of style of deployments and that type of processing, we really need to think about how we can incrementally deploy and pull back the logical view of our application. So that's where we came up with the Ortelius open source project. Ortelius is a microservice management platform that versions, tracks microservices, figures out what the blast radius is, will provide an inventory across all the clusters, and be proactive in seeing how your microservice architecture is changing over time. Ortelius, like I said, is part of the CD Foundation, and it's an incubating project in that governance. Our mission is to simplify adoption of microservices through a world-class management platform driven by supportive and diverse global open source community. So in the open source community for Ortelius, we have contributors from all over the world, all different skill levels, and if you're interested, please come join us. So how does Ortelius help evolve the Jenkins pipeline? Well, one of the things that we need to look at with microservices and Jenkins is we have to look at the data that we want to get out of Jenkins and how we can bring that back to give us that logical view of an application. So whenever we build a microservice, we're going to hook into the Jenkins pipeline, and we're going to track that that microservice has been created. And also, we're going to look at the relationships that that service has to not only other services, but also to the application level. This allows us to do a level of bill of material reporting. We can do that at the individual microservice level, or we can roll up to the logical application view. We can produce difference reports so we can see what's changed between one version of the service to another version. But better yet, we can see what's changed between a version of your application and another one. Like I said earlier, when we get into hundreds of microservices, we're actually going to find that a small subset are going to be the frequent changers, maybe 15, 20%. After a while, we'll have 80% of that code base, and those microservices are going to be pretty static. We may get some bug fixes along the way, but those will become pretty solid. And because of that, we can incrementally deploy our application and just deal with the change. So difference reports is very interesting in that area. And also the blast radius, like I said earlier, who's consuming my service and how am I going to affect them? And then who owns the service? How do we get in touch with them? What is the Slack channel or the Discord channel? What's the project owner's email address? That type of information. So if we have problems with it and we need to dive into the hood, we know who to talk to at that level. Then also through the integration between Ortelius and Jenkins, we're able to bring back that logical view of the application. And this will automatically allow us to do a level of versioning that we lost when we stopped publishing a monolith to a repository. So Ortelius will bring that back to the picture for us around microservices. So it's really reimagining how we can use Jenkins and leverage its power with Ortelius to give us the information that we need to be successful. So where does Ortelius fit into our pipeline? So one of the things that ends up happening in our Jenkins pipeline is we'll actually end up doing a Docker build. And as part of the Docker build, we end up pushing, after that's been completed, we'll push that result up to a Docker registry. Once that's complete, Ortelius is going to step in here and gather information about that service that was just created. Some of the things that we're going to track is going to be like the git commit, the branch, the repo, also where was this image pushed to, which container registry, what was the tag, what was the SHA, those type of things is what we need to know at this level of the pipeline. The next, depending on how we set up our pipeline, if we're going to do an automatic deployment or if we're going to have a gated pipeline, doesn't really matter to Ortelius, but what will happen is we will need to do a deployment. The deployment can be done by Ortelius. It has a deployment engine built in, or you can use another deployment tool and Ortelius record what that other deployment tool has done. But in the end, what we want to do is track where this component that we just created, or this microservice that we just created, where did it go to? And that gives us that map to let us know how things are put together and where they are living in the runtime environment. So what we do on the Ortelius side is we use our RESTful APIs to interact with the Jenkins pipeline, and we store this metadata that we're collecting, this catalog data, around the microservice and pushing it up into the Ortelius Postgres database. So if you're interested in getting started with Ortelius, you can use the DeployHub free SaaS version, or you could do the online version. There's a couple links for you to look at on how to install on-prem or sign up for the team version there. You can also reach out to our Discord channel to get any information, any help on that process. So how do we actually get this done inside of Jenkins? So there's a couple ways. The way that we're going to go over today is the Ortelius Groovy library. That's out in our Git repo. Also, we do have a Python library, as well as a command line and a Docker image. So in this case, we're going to go over the Groovy library because it gives us the most flexibility. So here we're adding in the Git repo for where that library is going to come from, and we're just going to pull off the master branch there. So what this is going to allow us to do is load in the Ortelius library. Here's a sample Jenkins file. One of the things that we're setting up here is after we clone our code from the GitHub, we're actually going to track information about what's being built. In this case, we're setting up some parameters for how to connect up to our Ortelius instance, and we're defining what we call a component. A component in Ortelius is the same thing as a microservice. You can have components of many types. In this case, we're going to be talking about Docker components in Ortelius. So we set up our component name, our application name that this component is going to be consumed by, what our version of our application is, what the image name is going to be when we push it up to our repository, and we set a few other parameters as part of this process. So basically, this is a lot of this information we can gather from your Jenkins environment. You know, if you have a standardization on like the project name, workflow name, you know, global environment variables, all that information can be pulled together from your Jenkins world. So our next step is we actually have to create our component. So after the build's been completed and we've pushed to the Docker registry, we want to go ahead and create a new version of our microservice, our component. And this is where we're going to pull together attributes from the Jenkins environment. Like in this example, our build number is being pulled from the Jenkins build ID number. And then other things, you know, the chart version, that type of thing, just some attributes that we're going to set at that level. So what this allows us to do is we will actually create a new version of the component. If one doesn't exist, we'll go ahead and create the base one. And if one does exist, we'll take the previous one and use that as our starting point and keep on iterating up the version chain, which with the new definitions. So after we do the component creation, we're actually going to take those attributes and assign them to that new component version. So this is where we're making that link between what Jenkins and Docker have and storing that inside of the Ortelius database, which allows us to then down the road when we do deployments reference that information. And then our next step after we update our component attributes is we're going to create a new application. Again, this will go ahead and look for a previous application version. If there's one there, we'll go ahead and use that. And then we'll incrementally apply this new version of the component to that application. So this allows us to do that incremental updating of our logical view of our application from Jenkins. So it makes it very easy to self-maintain your versions of your application and your components through the Ortelius Groovy library. So next, we're going to go ahead and add a few attributes to the application. So attributes, you can think of them as key value pairs or config map data, can be assigned to components, applications, environments, or endpoints. And that's what we're doing here. We're assigning a couple more parameters to the environment as well as the endpoints. So this is giving us all that configuration data stored inside of a central repository in the Ortelius database, which we can reference. We can get do reporting upon. We can do those questions that we asked earlier. What's my bill of material? What are my differences? Those type of things, impact analysis, those types of questions that we need to answer. All that data, all those relationships will be inside of Ortelius. So this is kind of a look at what happened as we went through our build process for a component. We can see that the Jenkins job that actually kicked it off, the build number, the build URL, you can see the container registry, the digest, the tags, what was the git commit that triggered this whole process moving along. All this information we're going to be gathering from the Jenkins pipeline. We can also store additional information at the component level or at the application level around, service catalog information. Like I said, who's the owner, what's the Slack channel, what's the PagerDuty service URL, what are the CVEs licenses that are being consumed by the service, what are the underlying pieces of the service. So all that metadata, all that service catalog information is rolled into Ortelius for your use later on when you need to get to that type of information quickly. So our next step is that we ended up doing when we assign the component to the application version is where we actually updated this map. So this map lays out all the dependencies that are in our logical view of our application. And as part of our CI/CD integration to Jenkins, we'll self-maintain this. So we'll find the previous version of a service and we're making an update to it. So we know that we need to replace that one as part of that process. So we can see that we'll end up with a lot of microservices, like I said, and they'll have different locations that they can be stored in. In Ortelius, we can organize our services into domains around a domain-driven design. So here we can see that the one that's highlighted is in the cart service domain. The one right below it is in the checkout domain. So this gives us a way to logically group together microservices regardless of the Jenkins organization and the workflows there. Because the workflows are pretty flat, we don't get a lot of organization. We can put some into it, but if we want to get crossover business silos, Ortelius can do that for you through the domain-driven design. So we can have one team pushing to cart service domain and another team that's using a totally different, it could be even totally different Jenkins instance pushing to the same cart service for their cart service type of microservice. So this allows us that smart tracking of what's happening at the microservice version level. So from there, we'll actually roll up and package together all of the services that we want in a version of the application. So in this case, we have a couple versions of our hipster store Labor Day sale. And you can see the latest one is the 10.0 version. Now this one was built based on a 9.1 version. So the only thing that's going to be represented there is going to be the differences. So it makes it very easy to get a nice view of what's changing from version to version of our application. Even though everything's spread out, we have hundreds of microservices across multiple Jenkins pipelines, multiple Jenkins instances possibly. We're going to pull all that together with Ortelius and give that logical view back of what your application looks like. And what this allows us to do when we start looking at an application is give us our BOM report. So we have two versions of our web store there, and we can see where things are being shared and where things are new versions being consumed. So if you see a orange box there with 2 arrows, that's actually a shared service between the 2 different versions of the application. The ones that have a single arrow, those are independent, like new versions of a service that the new version of the application is consuming. So that really gives us a look at how our application is being put together, what we're consuming. If we go over to the right where the blast radius report is, this is where we're looking at it from the other viewpoint. I have a service, who am I going to affect? So in this case, our cart service is affecting 3 different application versions. And that's important to know if we need to fix a bug or if we have to break backward compatibility upon it. We know who we need to talk to at that level. And this will span across business silos as well. There's not Ortelius is designed for collaboration and allow you that visibility across project teams. And finally, at the bottom, we have the difference report. Like I said, Artillerius can do deployments, and what it does, it can do them in an incremental fashion. In this case, when we deployed our new version of our application, we just ended up deploying the new version of the cart service. All the other microservices out there were the same. What that means is our deployments are much easier. We understand the impact of if something breaks, what changed. We can actually say, oh, we just deployed the 150 version of the cart service. Let's roll that back and isolate that to be the one that's causing the problem. So the difference reports allow us to do that type of insight into what's happening at the environment level. So that was a quick rundown of Ortelius and how we fit into Jenkins. If you have any questions, please contact us. You can get in touch with me on LinkedIn, or you can go out to the Ortelius website, ortelius.io. You'll see how to get on our Discord channel. The main repo for Ortelius is Ortelius/Ortelius in GitHub. Follow us on LinkedIn, and if you want to follow me on Twitter or on LinkedIn, there's my handles there, SBTaylor15. So thank you very much, and reach out if you have any questions. Hi there, everybody. So if you have any questions, looks like they're giving us like 1 minute to answer any questions. I've been answering them as we've been going along. Also to let you know that there is another demo that we're going to be doing at this afternoon in our booth, I believe 4:15 Mountain Time. So stop on by, and it's in between the break at the top part of the day. So we'll talk to you then.